Good day, guys. I hope you're good. So today we'll be doing the ear, right? Yesterday we did the eye. Today we'll be proceeding to the ear. Okay, let's just jump right into it without wasting any time. Right. So this is the structure of the ear, right? As you can see, and this is just the structure, just showing us an overview of the ear. Here at first we have our pinna, right? Our pinna. This is a clear display of a pinna, right? You know what the pinna, you know what its function is. It traps sound and directs that sound towards the auditory canal. This is the auditory canal, right? Auditory canal. And after the auditory canal, we have our tympanic membrane or eardrum, right? Our tympanic membrane or eardrum. So this is just an overview, right? Then our pinna combined with our auditory canal and our tympanic membrane, they form the outer ear, right? Even though our middle, even though our tympanic membrane is part of the middle ear, right? So it divides the outer ear, right, which is formed by the pinna and the auditory canal, right? So it divides the middle ear and the outer ear. Then in our middle ear, we're starting with our tympanic membrane, as I said, that our tympanic membrane forms part of the outer ear, right? And our middle ear. I hope that makes a lot of sense, right? Okay. Then our tympanic membrane here is connected to three smallest bones in the body, right? So the first bone in our middle ear, we have our hammer, right? Hammer, anvil, and stirrup, right? There are three smallest bones, and they're connected. Our stirrup is connected to our oval window, right? Oval window. So that's the middle ear. So the hammer, anvil, and stirrup, they form part of the middle ear. Then our oval window, right, connects the inner ear and the middle ear. I hope that makes a lot of sense, right? Okay, so this is our oval window. Our oval window is connected to our inner ear rather, right? So our oval window is connected to our cochlea. This is our cochlea. It's a snail. The snail-like structure, right? That spirals is called what? The cochlea. And inside the cochlea, we find the organ of Corti. Right? We find our receptor called what? Our organ of what? Corti. Right? And at the top of our cochlea, we have three semicircular canals that are responsible for balance. Right? Responsible for balance. And at the base of those semicircular canals, we have our ampulla, where we find our balance receptor cristae. Find our balance receptor. We're going to get into this, right, in a more detailed version, right? So this is the overview of an ear. So we have our outer ear, which is formed by our pinna, auditory canal, then lastly our tympanic membrane. Then our tympanic membrane divides the outer ear and the middle ear. Our middle ear starts with the tympanic membrane. You have your hammer, anvil, then stirrup. Then lastly, you have our oval window that forms part of the middle ear. And our oval window, right, leads us to our inner ear, right? Our inner ear our oval window is connected to the cochlea, right? The spiral structure, right? And inside our cochlea, we have our organ of Corti, right, which is a receptor. And then at the top of our cochlea, we have our semicircular canal that are responsible for balance. I hope that's clear. Also, there's an auditory nerve that's connected to to both the semicircular canals and cochlea, right? We'll get to that nerve and explain it further. Okay, so let's get into it. Fast. Okay, so let's start with the structure of our outer ear. So this is the structure of our outer ear, right? So our outer ear is formed by our pinna, right? This is the pinna. So what's the function of the pinna? It traps sounds and directs it to the or through the auditory canal, right? So this is our auditory canal, through our auditory canal, right? So this is the auditory canal. So what do you find inside this auditory canal? You find wax, right? Find cerumen, right? Cerumen gland that produce or secrete wax. So this is where you find your wax, right? And our auditory canal, it leads to our tympanic membrane, right? Tympanic membrane. So what's the function of our tympanic membrane? So tympanic membrane, they transfer sound waves to the bones of the middle ear, right? So they transfer sound waves to the bones of the middle ear, right? We'll get to those bones. So just know that our outer ear is formed by our pinna, auditory canal, and lastly our tympanic membrane, right? Okay, let's continue. Okay, and remember we stated that the function of the auditory canal is to transmit sound waves to the middle ear, right? It transmits sound waves to the tympanic membrane, or you can say your eardrum, right? And within your auditory canal, there are cerumen glands that contain or that secrete wax, right? So they secrete wax. I hope that's clear. Okay, let's continue. And also, you always have to remember that our outer ear is air-filled, right? It's air-filled. Our outer ear is air-filled, so it's just filled with air. I hope that makes a lot of sense. It's important for you to know that because when we get to the inner ear, you will then realize that our inner ear is fluid-filled, right? It's very important. And also, when we're dealing with the outer ear, we're only speaking about sound waves, right? We are speaking about sound waves only. Okay, let's move on. Let's get to our middle ear. Remember, we said our middle ear is formed by our hammer, which is the malleus. That's another name for a hammer, right? Our anvil, which is the uncus, right? And then lastly, our stirrup, which is the stapes, right? So you could alternate between those words. You choose which word you want to use, right? So we have our hammer, which is our malleus, right? Uncus, which is our anvil, and lastly our stapes, which is our stirrup, right? So we have those three smallest bones. They're three smallest bones in the body, right? Why? Because they amplify our sound waves, or you can say they amplify vibrations. Because when it comes to the middle ear, now we're dealing with vibrations. We're no longer dealing with waves, sound waves. There's a difference between sound waves and vibrations. So in the middle ear, we are now dealing with sound vibrations, right? And in collection, when they are your hammer, your anvil, and your stirrup, they are called the ossicles, right? They are called the ossicles. Okay. And also the middle ear, you have to pay attention to that. The middle ear is also air-filled, right? It's also air-filled. Okay, now let's go to the middle ear structure and its function, right? So we said we have our eardrum. Remember, our eardrum divides the outer ear and the middle ear. So this is the eardrum. What's the function of the eardrum? So it transmits sound waves or sound vibrations towards the middle ear, right? Because now we're entering the middle ear, we're no longer dealing with sound waves, but we're dealing with sound vibrations, right? Then after our eardrum, we have our ossicles, which are medius, ancus, and stapes, or hammer, anvil, and stirrup, right? So they are the three smallest bones in the body. Why? Because they amplify uh, sound vibrations. And when they amplify the sound vibrations, they transfer them from the middle ear, right? From the eardrum to the oval window, right? So they transfer them from the eardrum to the oval window, right? So what's the function of the ossicle is to amplify and transmit sound vibrations, right, towards the inner ear. Remember, what's connected to the inner ear? Your oval window. So there's an oval window here that's connected to the inner ear. We'll get to the inner ear, right? Okay. And also before I forget this, you have an Eustachian tube, right? A tube that's in your middle ear that's connected to your throat, right? So what's the function of this Eustachian tube? So the function of this Eustachian tube is to equalize pressure on either side of the eardrum, or to equalize pressure on either side of the tympanic membrane, right? So it equalizes pressure, this Eustachian tube, right? But we'll get to the Eustachian tube. Okay, so now let's look at the structure of our middle ear and the amplification of sound. I almost butchered that word, amplification of sound. Okay, so let's look. This is our tympanic membrane, right? So our tympanic membrane is connected to our hammer. I'll just use the normal English words. Connected to our hammer, right? Which is larger in size, right? And our hammer in turn is connected to our anvil. Then our anvil is connected to our stapes, right? Then our stapes is connected to our oval window, right? So what happens? The area of the tympanic membrane is much larger than the area of the stapes and the oval window. As you can see here, the area of the tympanic membrane is much larger than that of the oval window and the stapes. As you can see the size, right? The tympanic membrane has a larger size as compared to the stapes, right? And also another point that is important for you to know is that the ossicles they decrease in size from the hammer to the anvil to the stirrup, right? Why? Because the purpose of that is to amplify the sound vibrations. So the sound vibrations they get amplified much more, right? So they get amplified. So this is the overview of how the tympanic membrane is much larger than the stapes and the oval window. So to amplify sound vibrations, right? Okay. Okay. Now let's look at the part sound through the ear, right? Let's look at hearing. So what happens when it comes to hearing, right? So the sound waves are directed towards the pinna. The pinna traps the sound waves, right? Then directs them through the auditory canal, right? Then the auditory canal will transmit the sound waves, causing the tympanic membrane to vibrate. So the auditory canal, repeat that again, will transmit or direct the sound waves towards the tympanic membrane, causing it to vibrate. And the vibrating tympanic membrane will cause the ossicles to also vibrate. What are your ossicles? Your hammer, your anvil, and your stirrup. Your hammer, your anvil, and stirrup, right? And your hammer, anvil, and stirrup, or your ossicles, will amplify sound vibration, thus transferring them from your tympanic membrane to your oval window, right? And the oval window, which will cause the oval window to vibrate. And when the oval window is vibrating, it will cause, right, pressure waves. It will create pressure waves in the inner ear, right? It will create pressure waves in the inner ear. Remember, when it comes to the inner ear, we're no longer dealing with vibrations, we are dealing with pressure waves, right? I hope that's clear. So we're dealing with pressure waves. So the vibrations in the oval window will cause pressure waves in the inner ear, right? That will cause pressure waves in the inner ear within the cochlea. Remember, within the cochlea, there's an organ or there's a receptor we find called the organ of Corti. The organ of Corti will be stimulated by those pressure waves, right? It will be stimulated by those pressure waves. Then it will take the sound stimuli and convert it into an impulse, right? Stimulus is the change, which is the sound being converted to an impulse. What is an impulse? An impulse is an electrical message, right? Then after that stimulus is converted into an impulse, it will be transferred or transmitted by the auditory nerve to the cerebrum, right, or to the brain. So that's the process of hearing, right? So it will be transmitted to the cerebrum by the auditory nerve. I hope that makes a lot of sense, right? Okay, let's start over again and explain the whole thing. So the sound waves are trapped by the pinna, and the pinna will direct the sound waves through the auditory nerve. Then the auditory nerve will direct them to the tympanic membrane, causing the tympanic membrane to vibrate. When your tympanic membrane is vibrating, it will cause the three ossicles to vibrate also, right? So what's the function of the three ossicles? The three ossicles will amplify the sound that's transferring it from the tympanic membrane to the oval window, right? I hope that makes sense. Then the oval window will create pressure waves. It will create pressure waves in the inner ear or in the cochlea. Then in the cochlea, there's a receptor called the organ of Corti. And that organ of Corti will convert the stimulus into an impulse. Right? And then that impulse will be transmitted by the auditory nerve to the cerebrum or to the brain. So that's the process of hearing as a whole. All right? That's the process of hearing. I'm sure you might ask yourself that what's the function of the Austichen tube in the process of hearing, right? There's a round window here just below your oval window. That's here. It's not displayed here. There's a round window that's here. So the round window during the process of hearing, it absorbs excess pressure, right? That's created by the oval window. It absorbs excess pressure, right? And that pressure, right, is let into the Austichen tube, right? In order to obviously equalize pressure on either side of the tympanic membrane. So the round window will absorb excess pressure, and that excess pressure will go into the Austichen tube, then release through your throat, right? I hope that makes a lot of sense. So this is the path, it's the summary of the path of sound. So you're starting with your pinna, right? The pinna, from your pinna, you have your auditory canal. From your auditory canal, you go to your tympanic membrane. Then from your tympanic membrane, you go to your three ossicles, your hammer, anvil, and stirrup, right? Or you can say Melius, Ancus, and Stepi, right? Then from your ossicles, you go to your oval window, right? Then from your oval window, go to the cochlear fluid, right? Then from your cochlear fluid inside the cochlea, you get your organ of Corti. And from your organ of Corti, go to your auditory nerve. Then from your auditory nerve, you go to the brain, right? Remember, the brain receives and interprets each and every sensation, right? I hope that makes a lot of sense. Okay. And remember, I said that when it comes to the outer ear, we're dealing with sound waves, right? Sound waves. But when it comes to the middle ear, we're dealing with sound vibrations. But when it comes to the inner ear, we're dealing with pressure waves because there's fluid there. We're no longer speaking about vibrations or sound waves, but we're speaking about pressure waves. Then after pressure waves, we're speaking about the nerve impulse transmitted to the cerebrum. Yeah. Okay, let's continue with the structure of the middle ear. So this is the structure of the middle ear. So what happens to the middle ear? So the middle ear is divided, or the gateway to the middle ear is the eardrum, right? The eardrum is connected to your malleus, ancus, and stapes, or hammer, anvil, and stirrup, right? It's connected to these three bones. These three bones, they amplify the sound, right? They amplify sound and transfer the sound from the eardrum to your upper window, right? And there's this tube that's leading to your throat, right? It connects your middle ear to your throat. It's called the Eustachian tube. So what's the function of this tube, right? So it connects the middle ear with the throat, right? What's its function, right? It takes excess fluid from the middle ear, then drains it out into the throat, right? Or you can say that it equalizes pressure on either side of the tympanic membrane. Yeah, I hope that is loud and clear. Okay, now let's look at the phenomena of pressure, right? And how the oxygen tube performs its function. Let's look at scuba diving, right? So when it comes to scuba diving, the deeper you dive, the higher the water pressure becomes. So it means that the pressure, right? The pressure increases, right? So the pressure on either side of your tympanic membrane increases. I hope that makes a lot of sense. So the pressure inside your auditory canal is higher than the pressure in the middle ear because you're scuba diving. The deeper you go down, the pressure increases on your auditory canal. So now your stitching tube will allow you to drain out the excess pressure, right, through your throat. What are you supposed to do? You're supposed to blow, right, so that your stitching tube is able to drain out pressure or equalize pressure on either side of the tympanic membrane. So you're supposed to blow, right, so that excess pressure is equalized by the stitching tube, right? Okay, let's look at what happens when you go higher. So when you go higher, the pressure, right? The pressure decreases, right? But now what happens? The pressure in your middle ear becomes more than the pressure in your auditory canal. Or the pressure in your auditory canal becomes lesser than the pressure inside your middle ear. I hope that makes a lot of sense, right? So now your stitching tube has to equalize pressure on either side of the tympanic membrane, right? Yawning helps you to equalize pressure on either side of the tympanic membrane, right? Okay, let's move into our inner ear. So this is our inner ear. So our inner ear, right, is divided into our cochlea here. There's a round window. They included the round window here. Remember, what's the function of the round window? Function of the round window is to absorb excess pressure. It's very different from the stitching tube, right? The function of the stitching tube is to equalize pressure, but the function of the round window is to absorb excess pressure, right? Okay, so our our inner ear is fluid filled, right? And it's divided into our oval window. Remember, our oval window connects our middle ear to our inner ear. I hope that makes a lot of sense. Also, we have our cochlea. We have our cochlea, this snail-like structure, our cochlea. Then inside our cochlea, we find our organ of Corti, right? And we have this nerve connected to our cochlea and semicircular canal. We call that nerve auditory nerve, right? And we'll just say the function again. So the function of the auditory nerve is to transmit impulses to the brain, from the ear to the brain. Okay. Then we have our three semicircular canals, right? Which intersect each other at right angles, right? So they intersect each other at right angles. So they are perpendicular to each other. We can say that, right? So there are three semicircular canals. Then at the base of each and every semicircular canal, you have your ampulla at the base. That's where you find your balance receptor called the cristae. That's where you find your balance receptor at the base, right? Then below the ampulla, we have our utriculus, right, and circulus. Utriculus and circulus, right? What do you find inside the utriculus and circulus? You find another balance receptor called the maculae. Maculae. I hope that makes a lot of sense, right? Okay, let's continue with the structure of the inner ear. Okay, so the ampullae. Let's go to the ampullae. So the ampullae is just a bubble at the bottom of each and every semicircular canal. It contains cristae, which is necessary for balance, as I've already uh, iterated that it contains cristae, which is responsible for balance. Okay, and let's go to our utriculus and circulus. So our utriculus and circulus, it contains, right, a balance um, receptor called what? The maculae. So we'll get into the differences between the maculae and the cristae, but they both help in the maintenance of balance and equilibrium, right? But their functions, they react to different stimuli. Okay, well, let's go to our cochlea, right? So our cochlea is a snail-like structure filled with fluid, right? It contains a receptor inside called what? Called the organ of Corti. And this organ of Corti is stimulated by the movement of fluid, right? Remember, the pressure waves are created by the oval window, right? And those pressure waves, they stimulate the organ of Corti our cochlea, inside our cochlea, right? Inside our cochlea. So our organ of Corti stimulated by the movement of the fluid and converts the stimuli into an impulse. Okay, let's continue. Then we have our round window. Round window. So what's the function of the round window? It releases pressure created by the oval window. So it's excess pressure. So it absorbs excess pressure and releases it, right, to prevent echoing, right, or the distortion of pressure waves in the liquid, right? So the echo, the reason why your sound, like, you don't have echoes is because of the round window, because it absorbs excess pressure and then transmits that pressure into the Eustachian tube to be released through your throat, right? Then we have our auditory nerve. So our auditory nerve, it contains two nerves that merge into one, right? Then they transmit nerve impulses to the cerebrum with regards to hearing. But when it comes to balance, the impulses are transmitted to your cerebellum. Okay, there are two ways in which the inner ear regulates balance, right? I would like to introduce you to acronyms, your SIDS and SAMS. So let's look at the first way. So when the direction and speed of your head changes, right, that stimulates a receptor at the base of your semicircular canal, right? What's the base of your semicircular canals? Your ampulla, right? Your ampulla. So inside your ampulla, you find what? Cristae. Cristae. And your cristae will convert the stimulus into a nerve impulse. And then that nerve impulse will be transmitted by the vestibular branch of the auditory nerve to the cerebellum. Then your cerebellum will send impulses to your muscles to maintain balance. Hence, we have this acronym called ACIDS, right? So ACIDS. So A stands for ampulla, C stands for cristae, I is just for us to make to make an acronym sounds uh, so that you can spell it, right? So I does not mean anything, but D is for direction and S is for speed, right? You can actually write the whole balance process by just looking at this acronym. So let's look at our assets. Let's look at our A. What happens, right? I like to start at the front. Let's start with the S, right? So when the speed and direction of your head changes, it stimulates the cristae way within the ampulla. So when you start at the front instead of at the back, it becomes easier for you to know the process. I will repeat again. So when the speed and direction of your head changes, it stimulates the cristae where in the ampulla, right? Okay. Now let's go to the second way. I will explain both ways into details, right? In detail rather. Okay, now let's go to the second way in which our semicircular canals or our ear maintains balance, right? So the second acronym is SUMP, right? So it's SUMP. Okay. So the change in the position of your head, right, with regards to gravity, stimulates the receptor called what? The maculae. Where is it based? Or where is it located? It's located in the sulcus and utriculus. So that's where SAMS comes from. So let's start here with P. We're starting in the front, right? So when the position, right, when the position of your head changes with regards to gravity, the maculae in the utriculus and sulcus, or sulcus and utriculus, is stimulated. Does that make sense? So it makes it easy for you to remember the whole process. But now let's get into the processes. And let's explain both processes in detail. Okay. Now let's start with the maculae, right? So what happens? So when the position of your head changes, the gravitational pull changes also, which stimulates the maculae way in your sulcus and your utriculus. Right? Then your maculae will convert the stimulus into a nerve impulse. And that nerve impulse will be transmitted by the auditory nerve to your cerebellum. Remember, when it comes to balance, your cerebellum is responsible, not your cerebrum. Cerebellum. Right? Then your cerebellum will interpret the impulse, then send impulses to the muscles. Then your muscles will be ordered to maintain balance. Okay, let's go to your. Okay, so they did not explain here. They did not explain the change in the direction and speed of your head, but I'll just explain it here, right? So let's go to the change. So when the speed and direction of your head changes, right, it does what? It moves, it causes the fluid in the base of your, or not the fluid in the base, right? The fluid in the semicircular canals to move. And when the fluid in your semicircular canal moves, right, it stimulates the cristae at the base of the semicircular canal, right? So what's the base of the semicircular canal? The base is called what? The ampullae, right? Then within the ampullae, you find the cristae. The cristae is a receptor. So the cristae will do what? The cristae will convert the stimulus, right? What is the stimulus? The change in the direction and speed of your head. So the cristae will convert that stimulus into an impulse. Then that impulse will be transmitted by the auditory nerve, right, to the cerebellum. Then your cerebellum will send the impulses to the muscles, telling the muscles to maintain balance. And also remember this, the Christie is for direction, is the change in the direction and speed of your head. Right? This happens a lot in people who are um, who who do ballet, right? Because the direction and speed of their head changes, right? And the maculae, they deal with the position of your head. So whenever you're falling, when you're falling, right? So when the position of your head changes, it stimulates the gravitational pull, and the gravitational pull in turn will stimulate the maculae in your circulus and your utriculus. So that's the difference between the cristae and the maculae. Okay. Now let's look at hearing defects. Right. So these are hearing defects. Right. So possible causes of hearing loss. So what causes hearing loss? So hardened earwax can cause hearing loss because now means that nothing will pass through the sound waves. There will be a disturbance of sound waves in your auditory canal, right? Or your tympanic membrane can rupture. So when your tympanic membrane ruptures, obviously it means that the sound vibrations are no longer transmitted to your ossicles, right? Or your ossicles could be damaged, right? If your ossicles are damaged, it means that you cannot transmit vibrations the from the middle ear to your inner ear, right? Or the cochlea can be damaged. That's when now you need a cochlear implant, right? The cochlear implant. So your cochlea can be damaged. We know that when your cochlea is damaged, it means that you can no longer convert the sound stimuli into an impulse, right? Or your auditory nerve could be damaged. So if your auditory nerve is damaged, it means that you can no longer transmit impulses to your cerebrum, to your brain for interpretation. Or you can be brain damaged. Right? So when your brain is damaged, it means that your cerebellum or your cerebrum no longer works, right? But in this case of hearing is the cerebrum. Okay, let's look at diseases and disorders. Let's look at middle ear infection. So what happens with middle ear infection? So middle ear infection, an infection is caused by microorganisms, right? Which cause the production of fluid here in your middle ear. And they cause your eustachian tube to swell. So there's a swelling, as you can see here, is inflamed. Your eustachian tube is inflamed. So it means that those fluids cannot move out of the middle ear, right, to your throat to be ejected out, right? So what happens? This causes an infection, right? It causes an accumulation of fluid in your middle ear. Remember, you're not supposed to have fluid in your middle ear because it will impede the movement of your ossicles. So it means that the ossicles will no longer be able to move freely, right? So what do we use in order to treat what do doctors use to treat this middle ear infection? They use antibiotics. They can use antibiotics in order to kill the microorganisms, or you can use grommets, right? If it's chronic, so grommets. So grommets are inserted in the tympanic membrane in order to drain out the fluid in the middle ear. Okay. So these are grommets. As you can see, they are just plastic buttons that are inserted in your tympanic membrane in order to drain out the fluid from the middle ear, right? So they're draining out the fluid from your middle ear because when there's fluid in your middle ear, it means that your ossicles, those three bones that amplify sound, they can no longer move freely, right? Okay. So it allows the drainage of fluid from the middle ear. Yeah. Okay, now let's go to different treatments of hearing loss or disorders and everything. So these are the treatments. So you can have hearing aids. So this is a hearing aid, right? As you can see, this is an ear mold, right? Ear hook. Then you have your speaker here and a microphone, amplifier. Obviously, amplifier, it plays the role of the oscillators and everything. Then you have the battery, so you can have a hearing aid, right, or cochlear implant. So it acts as so this is a synthetic cochlea. It's a cochlear implant, right? So you have your internal implant, hearing nerve, right? When you hear hearing nerve, well, it replaces the auditory nerve. Then sound processor, right? Obviously, it's cochlear implant, right? Processes sound, means that sound is converted from a stimuli to an impulse. So it acts as a cochlea. Remember, inside the cochlea, we find the organ of Corti that converts stimuli into impulses, right? Cochlear implant, or you can have your different. So this is a cochlear implant. This is your hearing aid, right? It's just an example of your hearing aid and your the cochlear implant, right? Okay. So these are questions. I think we're done with the year. I think we're done with the year. Okay. Okay, we're done for today, guys. Then next time we will be doing the endocrine system or the response, responding to the environment in plants. So we'll be explaining more about that. Thank you.